Hello, everybody. This is Bhavana Bisht. Good morning, good afternoon, or good evening, whatever time of the day you're watching this. Welcome to the session. Hi. This photo is me, and this name you see over here is also me. I know the photo and me might look a little different, but we are the same people. That's right. So, hi guys, I'm Bhavna Bisht. I've been teaching for 2.5, actually more than that, years. I have done my master's in botany, and most of you are like, "Ma'am, botany kya hota hai?" So, botany is basically study of plants. Yes, correct. And I know Hindi, English, Marathi. So I would be switching between Hindi and English to make you understand better because most of you want me to do that. And as it is a recorded session, I won't be able to explain it to you again, right? Exactly. So let's begin with the session. Yes. So before going in with like full on, as you must have read the title, and we are going to study about structure of the atom. That's correct. We have just now finished with the atoms and molecules chapter, and there was a menti quiz scheduled for today. But as we could not take it, we will be taking it in the next month. So we are starting with structure of the atom. Okay. Before we go into all of that details, just if you are not a part of an academy yet, or an academy plus as of that matter, you need to come to an academy app and check us out because we are amazing. And if you are already on an academy, what are you waiting for, guys? You should be already with the plus subscription. That's right. But ma'am, what is plus subscription? How much do I get it for? And what is the quality? So let me tell you one very important thing, and that is it is the most cheapest and the best quality education that you're going to get there. Exactly. And if you don't believe me, check this out. You have around 1,000 rupees per month, and you are in ninth standard. You can join with K12 subscription where you have 9th, 10th, 11th, and 12th. 4 years together for less than 1,000 rupees per month. Isn't that amazing? Mhm. And you don't believe me, you don't need to. Why am I asking you to do so? Because we have live classes for all the subjects, not only science, mathematics, history, geography, but for all classes that you have, all the subjects that you have in your school, weekly quizzes, doubt solving sessions, practice questions, and test series, everything at your fingertips. That's correct. And you know what? I am damn sure most of you are watching me right now. You're sitting, you have your headphones on, but some of you are just having your done lunch, breakfast, or dinner. Some of you are just lying in your bed and enjoying the chapter, right? Yes. So, what is the best part? You can have it all. You can have live classes, weekly quizzes, doubt solving, practice session, test series, everything from the comfort of your houses. That's correct. So what are you waiting for? Mm-hmm. And you'll be like, ma'am, just plus? No. We have come up with another subscription that is called as the iconic subscription. And what is the best about this subscription is you get a personal mentor. That's right. When you're like, oh, I don't understand this. I want to get clarification on this. And you just pick up your phone, you call your mentor, and your mentor will guide you through each and every step. And these mentors have 15, 5, 30 years of experience in this field. Exactly. We have live doubt solutions, parent connect, because obviously you and I over here do not like to tell our less marks to our beautiful parents because no, we are afraid. But you don't need to be because your parents need to be kept in loop. Otherwise, they would not be a great asset in guiding you. Yes, so that is what we need, and this is what we give you. Yes, and a study planner because I don't know about you because when I open the book, I'm like, ye padu, wo padu, ye padu, wo padu, kitna padu? Yes, so I need somebody to guide me, and that perfect guidance is the study planner, guys. Yes, these are the plans for iconic subscription, you can either go for the iconic subscription or you can go for the plus subscription. Nothing changes much, just all the 4 features that I told you. You can go for any of it and you will get to see me every day. And you know what, if you like me, you can use my code BBLIVE110, like 10, and you can learn from me or any other educator. So this one slide gives you all the information, right? Because if you don't understand English, no worries, don't. आप अपनी sessions अगर आपको English नहीं समझ में आती, attend your sessions in Hindi. And if you don't understand, अगर आपको हिंदी समझ में नहीं आती, if you don't understand Hindi, attend your sessions in English. No language barrier. And you can choose the time, you can choose the educator, it's all upon you. You are the decider. Like as correctly said, it seems like I am the god. Oh, this is a cute little video. Please enjoy it. La, la. So let's put our thinking caps on and let's crack it. So today we are starting with the chapter Structure of the Atom. Okay, are we ready for it? Because I want you to sit tight and let's begin, guys, because we have to crack it. Yes? Oh, there's nothing. It's all white. Why? Because I want to ask you a very simple question. Now, as you're sitting, you might have lots of objects around you, right? Like I have the writing pad, I have a book with me. Yes, I have your book with me. I have pens and pencils, right? See, I'm just moving around. And I also have boxes. See? Yeah. So don't you have all of these stuff around you? Yes. And when I ask you, what is this? You'll be like, things? That's right. But if you remember atoms and molecules chapter, what are things called in Hindi? What can I call it? Can I say everything that is surrounding us is none other than Padartha? Yes. What is the meaning of Padartha? Padartha is everything that is surrounding us is nothing but matter. Right? So when we studied the last chapter, I'm saying always last chapter because they are very much connected to each other, okay? So when I talk about matter, matter is made up of particles, man. Yeah, they are made up of particles, right? But what kind of particles? Are these particles divisible, indivisible, or what are they called as? So, ma'am, let me just check. Oh, right. The particles, the matter is made up of very small, indivisible particles of matter that is called as atoms. Remember? Which were called as Parmanu. Right? So we have the movie Parmanu, we have everything. Parmanu bomb, that is a nuclear bomb. Why? Because atoms. Right? So when I say the word atom, you're like, this is what is making my matter. You're absolutely correct. But if I ask you another question, and that question is this atom divisible or indivisible? What is it? Hmm? Hmm? Exactly. It is indivisible. But, ma'am, kya baat kar rahe ho? What are you talking about? I have heard that atom is made up of protons, neutrons, yeah, and even electrons. Yeah. So where are they? If it is not indivisible, how are these particles inside it? जादू हो रहा है क्या? So over here, although atom is not divisible, but atom, like every other thing, is made up of something, right? So it is made up of protons, neutrons, and electrons. That is correct. So what are these called as, ma'am? These are called as my subatomic particles. That is absolutely correct. Yes, why subatomic? Because they are present inside the atom. Atom is already so small. So just imagine how small these would be. So atom consists of subatomic particles, namely protons, neutrons, and electrons. Okay. We're going slow because you should understand each and every step about it. Okay. Now I have a very interesting slide for you. Oh, what is this? You have 5 seconds to answer in the comment section. What is this? Or just think to yourself, what is this? I see golas and golas and golas and circles. If I'm not wrong, this is our, obviously I'm not wrong, because this is our solar system. Yes, ma'am, we know who it is. Okay, but you remember the names of the planets? So we have Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But wait, why am I showing you this? You were studying science, right? Why did we come to geography? Uh-huh. So if you have opened your textbook at least once, yeah, some while back, right? And if you see, you'll see I have a circle. This might not look like a circle, but assume it is a circle. And then we have another circle. Yes, and then we have another circle, and then we have another circle. What is all this? So somewhat it says this is the structure of atom in your book. Yes. And when I look at the structure, don't you remember something like this? That is our solar system. Yes, that is where the sun is in the middle and all the planets are revolving around it. But and rotating also, but are they revolving just AC? Like nobody is guiding them, nothing is there, huh? They are like, Thandavani happening on our solar system. No, right? We all know that Earth takes 364 to 365 days to complete one revolution. Ah, right. So, what is that? What is that? So, our planets revolve around the sun in particular orbits, right? Exactly. So, let's find out what is the relation between this diagram and our solar system. Okay, but first, let me try to fix my circle if I could. Mm, Okay, let's do one thing. Oh, we have a circle and circle and circle and circle. Oh my god. What is this circle inside a circle inside a circle inside a circle inside a circle called as? Do you remember it? Concentric circles, right? Yes, exactly. So when I talk about these concentric circles, but are we talking about them? No, we were talking about this, right? But we are doing structure of atom. So what is this all about? So, as I told you, we have the sun in the middle, right? So, similarly, in the structure of the atom, okay, we have a middle entity which is called as the, you already know it, and you have guessed it absolutely correct. That is the nucleus. Absolutely correct. So, what else, ma'am? So this nucleus over here, right? This beautiful nucleus over here. Okay, it is at the center. It acts like a sun, right? So does it have planets revolving around it? No, it does not exactly have planets revolving around it, but it has something called as electrons. That is correct. So electrons are revolving around the nucleus in circular path. But wait, even my planets do the same. They revolve, and what are they called as? Absolutely correct. These are called as the orbits of my planet. Similarly, the electrons move in a circular path, and this is called their orbit. So this is the orbit in which the electrons go around the nucleus. Yes. Okay, ma'am. So electrons have orbit, nucleus, but while we were studying, you told us that there is electrons, neutrons, and protons. So you told us nucleus, but where are protons and neutrons? So, my Tilda party, we have, let me change the color. So we have in the nucleus the presence of protons and neutrons. Protons are positive in charge, and hence whenever you write protons, you write it as P plus. Okay, so we have protons, which we write it as P plus. Okay, and when we talk about electrons, as they are negative in charge, we write them as E minus. Okay. Yes, so I have the atom where the center is occupied by the nucleus, the orbits, electrons, and the nucleus contains protons and neutrons. Okay, ma'am, I am understanding. But what is it related to the chapter? Like, this is not what my chapter starts with. Exactly, this is not what your chapter starts with. We are starting with the rare end, that is the later part, the last part of the chapter, and then we will go towards the first. Okay, so we are starting ulta because atoms and molecules mein humne padha tha, and this all stuff is very much related to it. So we'll continue that flow. Okay, cool. Very nice. So when I talk about all of these, ma'am, yeah, that's right. So what do I know? So you need to remember this beautiful, young, handsome, and amazingly intelligent man whose name was Niels Bohr. What about him, ma'am? So this entity right here received a Nobel Prize. That is right, a Nobel Prize for his work on the structure of atom. That's right. So how in just 10 minutes I told you that we have a nucleus, we have electrons which are revolving in orbits, right? What? To just know this crux that electrons revolve in orbits, the orbits which have a particular energy? Yes, that was discovered by Niels Bohr. Yes. And this amazing contribution of his, which I just told you in 10 minutes, took a lot of time and effort, not only from Niels Bohr, but a lot of scientists who were studying and trying to decode the structure of atom for a very long period of time. That's correct. So that is why he received a Nobel Prize in 1922. Okay. So what did he exactly do, ma'am? What did he exactly do? So when in the next session, we'll study about Thomson's and Dalton's model, and even Rutherford's model. Okay. So over here, he said that electrons move in discrete orbits around the nucleus. An electron will have its own particular orbit and it is going to stick to that orbit. That's correct. Okay. But how? How did it know that these discrete orbits, and why are they not radiating energy, huh? He is so confidently saying that they are not radiating any energy. So when we study, you will understand that when I have, when I have these, let me just bring another empty slide for us. It will be easier. I'm doing too many magic tricks, too many Jaduka tricks. So here is the empty slide. So when I talk about this, it says, now just imagine yourself, and I'm like, yes, you watching the video, you have to go to your nearest garden, you have to go to your nearest garden. Just assume this is your garden, and it has almost a rectangular shape. Yes, and you have to take one lap of it. Yes, you have to just go around the ground once, right? And you will be like, easy, ma'am. I'll just come back in 2 minutes, right? And you will go. Let me just change the color. Yes, you will go. Dash the you will complete one round, and you'll be like, ma'am, khatam. Kya ekdam easy task it was, right? But if I tell you, you have to complete 5 laps, what will happen? Hmm? Hmm? So like, okay, it will be a little difficult, but I can manage it, right? So you will go, you will take 1 round, 2 round, 3 round, 4 round, 5 round. But at the end of the 5 round, you'll be like, ma'am, I cannot do anymore, ma'am. I'm tired. I am tired, right? But if I tell you, you have to take 10 laps. So with every lap, you're losing energy, right? So similarly, it was assumed that whenever I have a nucleus and the electron around it, right? So when it is orbiting the nucleus, yes, it is losing energy and finally falling into the nucleus. Because as you were taking laps of the ground, you were losing your energy. Similarly, it is happening with my electrons. But Bohr was the one who told, hey, what is going on? This is not what happens. Exactly. Because these orbits around the nucleus have a particular energy assigned to them. So the electrons in them also have that energy and they are not radiating any energy. And that is why they are only revolving in that orbit. Yes. So this was a major contribution to the structure of atom given to us by the one and only Niels Bohr. Yes. So I hope everything is clear till now. If you have any doubts, please let me know. Okay. So, okay, ma'am, my electrons and my orbits and everything. But if I have many electrons, yeah, and I'm like, electron, can you tell me where does this electron live? First of all, you'll be like, ma'am, what is you're talking to electron? You're asking for electron. Will they not be confused? Yes. So we have to give them particular names so I can demarcate them very easily. I can understand here a cone kidhar hai, right? So that is why I have the nucleus, yes, which is filled with protons. Correct, absolutely right. And also neutrons. Ha, ma'am, right. Barabar hai, barabar hai, bilkul right, right. So, and the orbits also. But if I want to know the address of an electron, that will be very difficult for me. Yes. So, what do I do? All the orbits are also called as shells, and I give these orbits a very particular name. Yes. So let me do a namkaran for them. Yeah, let me just give them a name so it is very easy for me to distinguish. Yes. So the very first orbit nearest to the nucleus is called as the K shell, then L shell, M shell, and N shell. Yes. Now, how we have this amazing idea कि मेरा एक room होगा, I'll have my own room, I'll live in it alone, right? And I will decorate it however I want to. For example, in this class, however many students you want to watch the YouTube video, you can pass it on to your friends, and many of your friends, like all of your friends, can watch this video, like anybody all around the world. But if I talk about Unacademy Plus, only the people who have taken subscription can watch. Yeah, when I talk about Unacademy special classes, it is only the people who have downloaded the app can watch. Right, ma'am. So similarly, as we have limits to who can watch what, and how many people can actually, similarly, the K shell and the L shell, M and N shell over here also have their own capacities. Okay. Yes, so when I talk about capacities, it means that the K shell can only occupy 2 electrons. The L shell can only occupy 8 electrons, the M shell can only occupy 8 or 18 electrons, and the N shell can only occupy 32 electrons. That's right. So these are the capacities of each of the shell that they are going to have. Okay. So when I talk about these shells, K, L, M, N, as the K is the first one, it is given the name as 1. L is 2, M is 3, and N is 4. Okay. But ma'am, did somebody get the dream that K is going to have 2 electrons, L is 8, and M is 8 or 18, and N is 32? No. it was found out, and later on, a formula, you have a very easy formula through which you can decide, you can find out how many electrons are present in a particular shell, right? So what do we have here? What do we have? So we have the K shell. We have the K shell, which has what? K is the first shell. Yes, ma'am. So over here, N denotes the number of shell, like the position it is in. So when I talk about K, it will be 1. When I talk about L, it will be 2. When I talk about M, it will be 3. And when I talk about N, it will be 4. Okay. So you're like, ma'am, I want to find out how many electrons are there in the K shell. Yes. So when I talk about how many electrons are there in the K shell, so 2, what is N? N is the number, the position of the K, and that is 1. So 1 square, which is nothing but 2 into 1, because 1 ka square is 1, and you get the answer as 2. And how many electrons are present in the K shell? Electrons. Jadoo, right? Isn't it jadoo? Exactly. So this is what happens. Then let me change the color and we'll do somebody else. Okay. Let's talk about M. Yes. So when I talk about the M shell, let's put in the formula of 2n square. So M is, let me see, 1/3, right? So it will become 2 into 3 square, which is nothing but 2. 3 3s are 9. So this is 9 and it gives me 18 electrons. Voila! It happened, right? So anytime you forget ki ayya isme kitna electron tha, so just put 2n square as a formula and you will get the answer. Okay. Yes, absolutely correct. Now, what else, ma'am? What else? So K element 1, 2, 3, 4, 2n square. They have their own capacities. 2, 8, 18, or 32. Absolutely correct. Now you'll be like, ma'am, why 8 and 18? So just for your knowledge, this you will understand in 11th standard very better. For now, you just have to understand 8 electrons are there, then also it is half, like almost like half filled, and 18 is just like fully filled. Okay, so in both the cases it will be considered filled. Now let me just change the color. Yeah. Now how many electrons do we see? 2, 8, 18, and 32. But always remember, in the outermost shell, okay? Always in the outermost shell, always, okay? I'm very, very, very emphasizing always on the outermost shell. We are only going to have 8 electrons, okay? Not more than that. So any shell which you find, or rather it be 3 or 4, M or N, they are always going to have 8 electrons in the outermost orbit, okay? Why? And you'll be like, ma'am, but the capacity is 18 or 32, 8 or 18 or 32. So where these all other electron go? So basically, you'll just have this statement in your text, okay? This is not explained. You will get to understand much better in detail in 11th standard. But let me tell you one thing. So all of the remaining electrons go into something called as subshells. Okay, so all of these shells have more subparts and they are called as subshells. Okay, so whatever remaining goes to the subshell and then they are divided into the subshells, which you will study in 11th standard. Okay, because 9th and 11th are like bhai. Okay. Yes, so for currently, you just remember that outermost shell can only have 8 electrons. Cool? Yes. If you have any doubts, please put them in the comment section and I will make sure that I answer them. Okay? Yes. All right. So next, ma'am, we talked about electron and proton, but you never said what neutron is. You just told us it is present in the nucleus, but exactly what? Yes. So the amazing personality that you see on the screen is none other than J. Chadwick. So in the year 1932, he discovered another subatomic particle which had no charge. Exactly. I had proton with positive charge. I had electron with negative charge. But ये क्या हो गया? I have a particle with no charge. So that particle, my dear students, is none other than neutron, which was discovered by Chadwick, okay, in the year 1932. And another important part was its mass was equals to proton. And why not electron? Because if you take and weigh the mass of an electron, you'll find out it is very, 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 very less. It is almost negligible. Yes. So all the mass of the atom is concentrated to one position, and that is the nucleus. Okay, so in nucleus the mass of the atom lies, but in whose hands? So it lies in the hands of protons and neutrons. Okay, so neutrons have the mass equivalent to protons. Okay, so neutrons are present in the nucleus of all atoms. Okay, rather it will be a halogen or a noble element or anybody, whosoever atom it is, they are going to have neutrons present. Okay, except for hydrogen. Okay, so when we talk about isotopes, you will understand that part also. Clear? So remember the exception, this is very important. So what is neutron? Okay, so basically in the nucleus, this is the nucleus. In the nucleus, we have the presence of protons, which are positive in charge, and then we have neutrons, right, which are like neutral in charge. They're like, nah, I don't want to be positive, I don't want to be negative, I'll be just in the middle, I'll be neutral, right? So when I talk about neutral, it comes neutrons, and their mass is almost equal to protons, but they're always together. Don't you like all the nucleus, protons and neutrons together? So shouldn't we have a ship name for them? Yes, proton and neutrons, exactly. So together protons and neutrons are called as nucleons, correct? So where did this come from? As it is a no-brainer, so the nucleon came from here and the ons came from here. Yes, so nucleons. Sorry for the spelling mistake. So we have nucleons present in the nucleus, that is protons plus neutrons. So the mass of the atom is therefore given by the sum of masses of protons and neutrons present in the nucleus. That is, if anybody asks you what is the mass of an atom, okay? So anybody, let it be me, your mama, or anybody, mass of the atom, we all know is situated in the nucleus. And who has it? Protons and neutrons. And they have similar? Yes. But they are present together? Yes. So can I take a sum of it? Yes, you can. So it becomes P plus N. Understood? So P plus N is equal to mass of the atom, that is number of protons plus number of neutrons will give you the mass of the atom. Understood? Clear? I hope it is clear to everybody. Next is distribution of electrons. When I talk about distribution of electrons, we are already done with it. So the maximum number of electrons present in the shell is given by the formula 2n2, but 2n2 over here represents 2n square. Okay, the number of energy level, as you already know, K is 1, L is 2, M is 3, and N is 4. Similarly, it goes on and goes goes on and forth. Next, electrons are not accommodating unless the inner shells are filled. So you'll be like, ma'am, I have the nucleus, I have the K shell, L shell, M and N shell, right? And you'll be like, ma'am, you know what? I have 8 electrons, and I know that L shell has a capacity of 8 electrons, you know. So what will I do? I'll fill my L shell with all the 8 electrons, and I'll just leave the K shell empty. But you cannot do that, my dear students, because until and unless my K shell is filled, you cannot fill the L shell. Understood? So what is going to happen, ma'am? What is going to happen over here? What is going to happen over here? Let me just draw it again for you. So what will happen over here is I'll have the K and the L shell. The first two electrons will enter the K shell. Then the remaining 6 electrons will enter the L shell. Understood? Yes. So this is how we have distribution of electrons. It is a very stepwise manner, but if you're like, ma'am, if 14 electrons are present, what will happen? So 2, then this will be 8. I have 8 electrons over here, so 10 is already done. and more 4 are remaining. So then they will go on to the M shell. Clear? So stepwise filling of electrons is what is happening whenever we are like distributing electrons. Okay? ऐसा नहीं है कि एक को हम ज़्यादा चॉकलेट दे देंगे, एक को हम कम दे देंगे. No. या पहले सबको एक इंसान को पूरा चॉकलेट दे देंगे. No. When it's my birthday, I make sure that each and every bacha in my class gets at least 1 chocolate, right? Equal distribution, amazing distribution, how it is meant to be. Similarly over here also, first inner shells have to get filled and then only the outer shells are going to get filled. Okay, so these are some of the elements. Yeah, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. You have 18 atomic structures present on the slide. So what are we supposed to do? So we will take few examples from this and we will try to learn how the electrons are distributed using that 2-3 examples. Okay, cool. Again, another magic I have in store for you. And what is that magic, ma'am? Okay, now as I told you, we will be drawing the schematic atomic structure. So let's draw it. Okay, yeah. So, but first, let me try to make circles. Oh my God, these are looking bad shaped donuts. This can never be my atoms, can they? No. Does this have automatic ready-made atomic structure for us? Yes, because drawing circles is not our cup of tea today. Yes. So what will we do, ma'am? So let's just take one example and let's see distribution. So first we'll take hydrogen and then blah, 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 blah. Let's take neon. Yes. And then we will take sodium. Yes, we'll take these 3 examples and if need be, we'll see. Okay, so the first, when I talk about hydrogen, okay, so hydrogen has atomic number 1. So it has 1 electron and it has 1 proton. Okay, so when I talk about proton is the nucleus. It is no worries. I don't have to distribute it because everything is inside the nucleus. But when I talk about electrons, they need to be distributed in their particular orbits, right? So this 1 electron will go in the first orbit, right? And the first orbit is a K. What is the capacity of K? That is equals to 2, right? Absolutely correct. So, ma'am, until I achieve the 2, it is not going to go into another. Exactly. So if I have, let's say I have, what is the one with 2 electrons? That is helium. So when I talk about helium, let's take the example of helium over here. So when I say helium, helium has atomic number 2 with 2 electrons and 2 protons. Yes, ma'am. So if I have helium, let's trust our circles. So I will have 1 electron. Yes, and 1 more. Exactly. But, ma'am, if 3 electrons come then, so if I talk about lithium, atomic number 3, so I have 3 electrons, right? So what will happen? Another new shell will be added. Understood? And the 3rd electron will be put in the L shell because the capacity of K has been fulfilled. Understood? So when I talk about, let's take the example of neon. Yes. So when I talk about neon, the atomic number of neon is 10. That is 10 electrons. That's right. So I will have, this is the nucleus. So I have 2 electrons in the K shell, right? And then let's draw the electrons on the L shell. So 1, 2, then how many are remaining? 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Understood? Yes. So all of the orbits are filled. So my K shell has 2 electrons, L has 8 electrons, then they are completely filled, right? Completely filled. And that is why whenever we have orbits which are completely filled, these are called as noble elements. Okay, and neon is one of them. It's a noble gas. Understood? So because they are very less reactive, they do not require to react because all of their orbits are filled. Understood? Okay. So let's talk about sodium. That is Na. The atomic number of sodium is 11. Ayo, lafde ho gayi chi. What? So I have the nucleus. Yes, so let's, you know what, you can do another very interesting thing, and that is write the electronic configuration before drawing the diagram, and that would become 2, 8, comma 1. Understood why? Because the capacity of K shell is just 2, so K. L shell is 8, and then the 1 electron will go in the M shell. Okay, and then it becomes very easy to put electrons in. So K shell will have 2 electrons. Yes. Then L shell will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons, right? 10 electrons are already done. We have 1 electron remaining. Yes, and we cannot put any other more electrons. Why? Because that is the capacity of L shell, and that is why the last electron will go in the M shell. Understood? Yes. So this is how distribution of electrons happens even in real time. Understood? Yes. So this is some schematic atomic structures. So another example we can take is when we talk about argon. Okay, argon again has the atomic number of 18. So can I write the electronic configuration as 2, 8, 8? Yes. And don't you see that all of them are fully filled? Yes, ma'am. And that is why argon is also a noble gas. So 2 electrons in the K shell, 8 electrons in the L shell, and 8 electrons in the M shell. Understood? So do I require this shell? No. What is the requirement, ma'am? Because I already have all the shells which are filled, and that is only what my atomic number is. It is not going to go above it. And when all of my shells are completely filled, they become noble. Understood? Yes. Okay. Now, when we're talking about noble and everything, right? Can you answer yourself? Like you can answer this in your mind also. Like, what are you doing here? You are here watching me teach you, and you're watching Unacademy. You're watching all of these new skills that you want to learn. Why? Why are we here? Why are we here to learn? I'll give you 5 seconds to answer. You to yourself or in the comment section, whatever you like. Why are we here? Why? Why do we wake up every day? Why do we study? Why do we want to get good marks? And why are our parents insisting keep padho, study? Because studies are a very integral part of life. Why? Because they want us to be stable in life, right? They want us to achieve the best things possible. So we have a very stable economic condition and where we can live a happy, healthy life, because economics play a very important role, right? And it plays a very integral part on how I will maintain my health. So all of this, what are we doing, what our parents are doing, it is all to achieve that one stability in life, right? Yes. So if all my octets are completely filled like neon, it is stable, right? Because it has all the electrons that is needed. It does not need to go to anybody else and ask for electrons, does it? No, it does not require to. But then we have people like sodium, yes, who just have 1 electron in the M shell, whereas the capacity of M shell is 8 electrons. It is 7 electrons short. And it cannot be a noble gas. It cannot be stable because something is still not filled, right? Yes, absolutely. So to give everybody a chance to achieve the stability, we have something called as valency. That's correct. So what is valency, ma'am? I am so confused and I don't remember only what this valency is. So valency is actually the number of electrons which are present in the outermost shell of an atom. Okay, so most of the time, you don't even need to do a lot of things. You can just count the number of electrons in the outermost shell and you will get the valency. That's right. What is the outermost shell? As the name suggests, the shell, which is like the sabse bahar, which is like outermost. towards the end. Yeah, the end wala shell is the outermost shell, and how many ever electrons are present in there, that is the valence electron. Right? But ma'am, as you said, neon is a stable gas, right? It will not react with anybody because it's already stable. All these shells are filled. And over here in the outermost orbit, it has 8 electrons. So should I say the valency of neon is 8 electrons? No. Because over here, you will be introduced to another definition of valence electrons, and that is the combining capacity of the atom. Okay, so when I talk about the combining capacity, it means that how much electrons that can it give away or take in, because we have already studied ions in the chapter atoms and molecules, right? Yes, so when an atom gives away electron, it becomes a donor. Giving away electron gives us positive charge, right? Yes, but why does it give away? Why does it give away that electron? Because to achieve that stability, right? So over here, when I already have 8 electrons, do I need to give or take from anybody? Do I need to combine with anybody to get a stable configuration? No, I do not. Right? So that is why the combining capacity of neon is 0, and hence the valency of neon is 0. Understood? Yes, absolutely correct. So it was observed that the atoms of elements having a completely filled outermost shell show little chemical activity. But like, why should I show chemical activity? Because I'm already filled. I don't need to give my electrons. I don't need to take somebody else's electron because, I am filled. Yes, I am stable. And that is why the noble elements, noble gases, show almost what? It shows activity almost, which is near to none. Yes, correct. Understood? And that is why their valency or the combining capacity becomes 0. Okay, I hope the valency concept is very clear because I'm not taking a live session. I cannot see your doubts. I cannot understand what is going through your brains. And that is why I'm going very slow and making you understand everything in great detail. Okay. Yes, make sure of that. So please write down the definition of valency because it is very important. I'll give you 10 seconds. Do. 9, 8, 7, 6, 5, 4, 3, 1, and we're up. Okay, I hope everything is clear. If you have any doubts by in case, please put it in the comment section down below. I'll look at it and I will solve it. Okay, so make sure to do that. Oh my God, this is quite a big chart, and I think I need to change my position. Yes. Hi, everybody, in a new position. So why over here, ma'am? Because this chart over here gives you the valency of 18 elements. That's correct. So first is hydrogen. As we know, it has only 1 electron in the outermost shell because it has only 1 shell, right? Exactly. So does it need to do something? Yes, if it gains 1 electron, it will become stable. Why? Because the K shell will be completely filled. So I just need 1 more electron. So how many electrons are there in the outermost shell? 1. How much electron does it need? Like, what is the combining capacity? If it just takes 1 electron, it will achieve 2 and it will be filled, right? Yes. So the valency of hydrogen is 1. Okay. I hope this is very clear to everybody. So this is how hydrogen valency is 1. Okay. But over here, if you see and pay attention to helium, it has 2 electrons, right? Yes, atomic number is 2 electrons. Perfect. What is the capacity of K shell? Ma'am, it is 2 electrons, right? Can I take any more electron? No. Can't give away. Why? Because it is already stable. Why do I need to give away one electron? And hence, the valency of helium is 0. Understood? Yes. So again, when I talk about carbon, because carbon has the atomic number of 6, right? So K shell will have 2 electrons and L shell will have 4 electrons, okay? And what is the capacity of L shell? 8 electrons, right? So it has two options. It can either give away 4 electrons and attain the nearest noble gas configuration, or take 4 electrons and have 10 electrons, and which will be stable, neon, nearest noble gas configuration. Right. So what can it do, ma'am? So that is why it can either go give 4 away or take 4 in, and the number of electrons present in the outermost shell are also 4, right? So the valency of carbon is 4. So neon, everything is quite easy. Neon 10, 2 electrons in the K shell, 8 electrons in the L shell, sorry. And everything is filled, right? No need to give or take any electrons. So the valency is 0. Understood? And then chlorine has the atomic number 17. So when I write the electronic configuration, it becomes 2, 8, 7. Yes, so if I want to talk about 2, 8, 7, so I have 2 electrons in the K shell, 8 electrons in the L shell, and 7. 1, 2, 3, 4, 5, 6, 7. Right? So when I say 7, how much electron does it require to fill the M shell, right? So if I know M shell becomes stable at either 8 or 18 electrons, so I need to at least achieve 8 electrons. So for that, I just require 1 more electron. In the sense, my chlorine would require to gain 1 electron, right? Yes, to achieve the 8 wala number. Exactly. So what is better? What is better? To give away all the 7 electrons and then achieve the nearest noble gas configuration, or just take 1 electron? Which is easier? Like एक करके सब electrons को देना या एक electron को ले लेना? Yeah. So when you think about it, I'll give you 5 seconds to think about it. What is more easier to do? Rather than giving all of our energy, removing electron one by one, or just taking 1 electron? Yeah, yes. What do you think? What do you think? Exactly. So I can just take 1 electron and I will achieve the nearest noble gas configuration, that is 2, 8, 8, and that would make my chlorine stable, right? And exactly that is why the atomic, the valency for chlorine is 1. Okay. Argon is again 18, 2, 8, 8. All of my orbits are completely filled, and hence they become. So hence, argon, stable, all the shells are filled, and my valency is 0. Clear? Yes, everybody? Okay, so I want everybody to write this down. The combining capacity of the atoms. Let me just change my position because I'm obstructing. So, valency over here, the combining capacity of the atoms of other elements, that is, the tendency to react, yes, and form molecules with the atom of the same or different elements, right? For example, we have always seen hydrogen. Hydrogen is there in the atmosphere in the form of H2. But what happened over here? Hydrogen was like, koi nahi milne wala mere ko. Yeah. So it went to another hydrogen atom and he was like, you know what? Will you be my friend? And that was like, yes, I'll be your friend. And what did they do? 2 hydrogen having 1 electron each. They came with each other. They just shared their electron and they achieved what? 2 electrons in the K shell, and that is stable, right? So I find H2 gas all over in my atmosphere, right? Exactly. We have also studied about NaCl. Yes, what is the atomic number of Na? If you recall, can you recall the atomic number of Na for me? Yes. So Na has the electronic number 11, that is 2, 8, 1. Yes, and chlorine is 17, that is 2, 8, 7, right? So it needs to give away one electron to achieve the nearest noble gas configuration, and this needs to gain one electron to achieve the nearest noble gas configuration. Exactly, ma'am, exactly. So what do they do? So chlorine kickoffires one electron, and that electron is accepted by chlorine. Yes, and as a result, they form a compound that is called as NaCl, which we all lovingly eat as table salt, right? Yes. So over here, these electrons are making, yeah, they are transferring, they are taking, they are giving, and these transfer of electrons is making our molecules a reality. Yes. So this makes up the combining capacity, and this is what my valency stands for. The combining capacity of the atoms of other elements, that is a tendency to react and form molecules with the atoms of same or different elements. So NaCl different, H2 same element. Understood? So this was done as we just now saw that hydrogen share that electrons, like jo tera hai wo mera hai, jo mera hai wo tera. Yes, so when we have this amazing chemistry where we share things, that is also we are forming a bond, right? And when we share and form a bond, that is called as the covalent bond. Understood? When we gain and lose electrons, that is when we are forming a ionic bond. Understood? So number of electrons gained or also shared as to make the octet, like the outermost shell, completely filled, combining capacity. And this is how valency helps us to make elements. Understood? Oof, that is amazingly well done by you guys. Okay, so rather than going on to atomic number, and we have just 5 minutes remaining, and in this 5 minutes I would like to revise everything that we have studied till now. Okay, yes, absolutely correct. So let's go back in time. Let's go to need board. Yes, and we will begin from here. Are you ready? So this amazing man called as Niels Bohr over here was the first one to tell us that, oh, hello, electrons are moving in discrete orbits, and for that he received a Nobel Prize in the year of 1922 for his great contribution to the structure of atom. Okay. Yes, what did he say? Discrete orbits, they have their own energy level, and that is why when my electrons are going in, they do not lose their energy and they don't fall off. Rather, they keep on rotating in the same orbit. Yes, so this was a great contribution of Niels Bohr. And then we studied that electrons, yes, we have the atom, we have nucleus, protons, neutrons, and electrons. And the electrons are present in particular shells, and these shells have been given name. Obviously, otherwise I'll get confused. So we have K, L, M, and N shell. We have numbered them as 1, 2, 3, 4 respectively. They have their own capacities. So K has 2 electrons as its maximum capacity. L has 8 electrons. M has 8 or 18 electrons, whereas N has 32 electrons. They can only have 8 electrons in the outermost shell. Any further, they go into the subshells, which we'll study in greater detail in the 11th standard. And then we can know all about this by just applying the formula 2n square. Yes, absolutely correct. So then neutron, which did not have any charge, positive was protons, negative was neutrons, negative was electrons. Without any charge, we have neurons. So Chadwick was the one to discover that, and he was like, oh, this happens. But there's one element which does not have any protons, and that is hydrogen. Okay, so neutron is present in the nucleus. It is present with the protons. So both protons plus neutron together are called as nucleons, right? Yes, nucleons. Sorry. Yes. So they together give me the atomic mass. Clear? Then distribution. As I told you, they have their own energy and amazingly important part is that we have the nucleus KLM. So only when the K shell is filled, I will get electrons in the L shell, and only when N shell is filled, I'll get electrons in the M shell. Okay, there's no partiality, no favoritism, nothing. It has to get the inner shells filled first and then only the outer shells. Okay, then we study about some schematic atomic structures where we saw how exactly the electrons are getting distributed, especially based on their atomic number. And now most of you are like, ma'am, what is this atomic number? So that we are going to study in the next session. Okay. Then we did some examples. Then we did the last part is valency. So most of the times, if you're not remembering what valency is, because it is the most easiest part, and that is how many ever electrons are present in the outermost shell of the electron of the atom gives you the valency. Okay, we'll be like, ma'am, noble gas, yes. So valency of noble gas is 0, and it is also the combining capacity. For example, carbon, 4 electrons in the outermost shell, 4. But for chlorine, I have 7 electrons in the outermost shell. But what is easy? To give away 7 electrons or to take 1 electron? What is easy? Just to take 1 electron, right? Yes. So it is just going to take 1 electron, and hence my valency of chlorine is 1. Understood? Is this clear? Sorry. So valency is nothing but the combining capacity, and this combination can happen between same elements, right? Or it can happen between different elements, correct? Yes. So this same and different elements can happen by many factors, but over here, what plays a very important role is the number of electrons present in the outermost orbit, which are ready to get shared, lost, and gained, right? So as I was telling you, by sharing, jo tera hai wo mera. So while I share, it becomes a covalent bond, gaining and losing makes an ionic bond, and so on and so forth. All of these are making possible for the formation of a molecule. Understood? And that is what we require. Now, before moving on and completing this session, I will request all of you. Yes, we are already done with one part of that, but this is for you, okay? I know you're in 9th standard. I know you don't have the pressure of deciding what you want to do with your future, but this 5-star project was just done yesterday, and I hope you were a part of it. Now we have a career quest on November 28 and 29 from 10 a.m. Yes, the link is already, you have to register for it. The link is already on the Unacademy app. Go and register because it is a 2-day free summit for kids like you. You don't need to choose, but at least you can have an idea what are the fields available, and that can be amazing for you. Yes, so just do not miss the opportunity on 28th and 29th of November at 10 a.m. Okay, yes. So this is it for today's session. This is how we conclude the structure of atom. I'll see you in the next session with another continuation of this, or we might have a Menti quiz on atoms and molecules. Let's hope we have a Menti quiz. Yes. And this is it for today's session. Thank you so much for joining in. And it was amazing to meet you after such a long time. Thank you so much. Stay at home. Stay safe. Okay. Take care of yourself. Bye-bye.